Good morning. Welcome to this Conservation Applied Research and Development, or CARD webinar, which is going to report on the key findings from a rigorous billing analysis that sought to update two assumptions in the Minnesota Technical Reference Manual, or TRM. Thanks so much for joining us today. I'd like to cover a few housekeeping items before we start. All attendees will be in listen-only mode. We will answer all questions at the end of the presentation, but as questions occur to you, please type them into the Q&A box and send them to all panelists. The Q&A box can be opened by clicking the ellipse in the lower right-hand corner of your screen, as indicated on this slide. We'll do our best to answer all questions within the time allocated, but if for some reason we don't get to some, we'll answer them after the webinar and provide those to people. This webinar is being recorded and will be available on the department's website in a few weeks. The slide set from the webinar will also be available on the website, but if you need it sooner, just email me directly and I'll send it to you. Finally, if you'd like to use closed captions on this webinar, click the CC bubble in the lower left-hand corner of your screen. I'm Mary Sue Lobenstein. I'm the Research Planning Director at the Minnesota Department of Commerce, Division of Energy Resources. In that role, I identify and analyze gaps within utility conservation improvement, or SIP, programs, and coordinate and plan research to fill those gaps. The CARD program is a major tool of that work. With me today are Laura Silver and Adoy Day, who are also from the Minnesota Department of Commerce. Laura is a principal state program administrator at the department, where she reviews utility conservation improvement program triennial plans and annual status reports. Adoy is a public utility rate analyst for the Energy and Rates Planning Unit at the department, where he provides technical support and testifies for positions of the department on rate design, rate of return, cost recovery, energy conservation, and other issues in complex gas and electric utility matters before the PUC. Laura and Adoy were the Commerce project managers on the research being presented today, and Laura will be moderating the Q&A portion of the program. I'd like to introduce our presenters today, who are Amalia Hicks, Christy Amaro, and Matej Perusi from the Cadmus Group. As a principal at Cadmus, Amalia leads the pilots and technology assessment groups, manages portfolio-wide evaluation activities, including TRM updates, oversees economic impact analyses and potential studies, and assists in program planning and design for energy efficiency programs. Amalia acted as the principal investigator for these CARD projects. Christy is a professional engineer and senior associate at Cadmus, where she's dedicated to reducing fossil fuel use through strategic electrification and the implementation of energy efficient and renewable energy technologies. Christy was the project manager on these two projects. As technical specialist at Cadmus, Matej provides expertise in advanced statistical methods, billing analysis, advanced metering and infrastructure analysis, conditional demand analysis, and load analysis. Matej has conducted over 200 billing analyses and served as the primary data analyst for these CARD projects. Welcome to all three of you. We look forward to the presentation. To provide just a little more context before we start, this webinar is one in an ongoing series designed to summarize results from research projects funded by Minnesota's Applied Research and Development Fund, which was established in the Next Generation Energy Act of 2007. The purpose of the fund is to help Minnesota utilities achieve their energy saving goal. $2.6 million is set aside annually for the CARD program, which awards research grants and a competitive request for proposal process. As you can see by this pie chart, CARD projects funded to date have been in all building sectors, as well as some that cross multiple sectors. The subject of today's webinar is the residential sector, and we'll discuss results from two recent CARD projects that conducted billing analysis of Minnesota SIP participants to isolate thermostat savings and extract the heating and cooling equipment equivalent load, full load hours for use in Minnesota's Technical Reference Manual. Now I'm going to turn it over to Amalia to kick off today's presentation.
Thank you, Mary Sue, and good morning. This is Amalia Hicks. I served as the principal investigator for the 2 card studies that we're presenting on today. These studies were initiated in 2020 to collect and analyze Minnesota customer billing data and extract Minnesota-specific residential smart thermostat savings and HVAC equipment equivalent full load hours, or EFLH, for use in Minnesota's Technical Reference Manual, or TRM. So during today's webinar, we will explain the intention of these studies and the measures, the TRM measures impacted, an overview of the data collection and billing analysis methodology, thermostat savings and HVAC EFLH results, conclusions and recommendations for TRM version 4.0, and then wrap up with some next steps. We'll have time for questions at the end of the webinar, but if you have any burning ones, feel free to throw them in the chat or interrupt. So on to the background. I'll kick things off with an introduction as to why these studies were needed and the measures that may be updated based on those results. Starting with thermostats, programmable and smart thermostats have become popular with consumers over the last 5 to 10 years, and they can reduce heating and cooling loads by automatically adjusting temperature set points based on occupancy and outdoor air conditions. There are 3 thermostat tiers defined in the TRM. Tier 1 is described as a simple programmable thermostat, where a customer can program set points and schedules on the device itself. Tier 2 are communicating thermostats, where set points can be accessed and scheduled from anywhere using a smart device such as a phone, tablet, or computer. Tier 3 are analytics-capable thermostats. These models have additional energy-saving features beyond Tier 2, including HVAC diagnostics, demand response capabilities, and customer-specific engagement. Smart thermostats represent 25% of the natural gas and 10% of the electric residential savings potential in Minnesota, so they're important measures. However, the TRM 3.3 thermostat percent savings are informed by average savings from other Midwest states, including Michigan, Wisconsin, Illinois, Indiana, and those individual savings factors vary widely state to state. Also, the Minnesota TRM version 3.3 baseline natural gas and electric energy consumption values are based on monthly sales information from 2015 triennial filings and are therefore likely not representative of homes that are currently receiving smart thermostats. So on to HVAC. First, a quick definition. Equivalent full load hours, EFLH, are equal to the total annual heating or cooling energy consumption of an HVAC unit in BTUs divided by the unit's full load heating or cooling capacity in BTU per hour. And the unit capacity is collected from manufacturer's data or equipment nameplates. HVAC equipment measures make up a large portion of potential residential savings in Minnesota as well. 28% of the natural gas potential for high efficiency furnaces and boilers, and 22% of electric potential for high efficiency air conditioning units and heat pumps. However, again, the Minnesota TRM version 3.3 residential cooling and heating EFLH values are not Minnesota specific or recent. For furnaces and boilers, the EFLH in the TRM is based on a 2012 Illinois metering study and program data. For air conditioners, the EFLH is based on a 2012 California program data and modeling. And for heat pumps, the EFLH is based on furnace and boiler heating EFLH and air conditioner cooling EFLH values. But we know that heat pumps operate quite differently from furnaces and boilers. So while updated thermostat savings only apply to one TRM measure, the updated residential HVAC equipment EFLH values may apply to 13 existing measures, all listed here, which reference heating and cooling EFLH values in their algorithms. So now I will turn things over to Christy to discuss our methodology.
Thanks, Amalia. So this is Christy Amaro. I served as the project manager for these studies. And in this section of the presentation, we'll summarize the data collection and billing analysis methodologies that we use to determine the thermostat savings and EFLH. So at the start of 2021, we worked with the department and supporting utilities to obtain program and monthly electric and natural gas billing data for residential HVAC and smart thermostat installations. So we want to thank CenterPoint Energy, Minnesota Energy Resources, Minnesota Power, Ottertail, and Xcel Energy for providing program and customer data to support these studies. And while the provided data sets varied across utilities, the critical data fields for each of the measures that we analyzed are shown in the table here. So this slide summarizes the primary cohorts or specific participant groups that are defined by a variable or a combination of variables that we analyzed using the program data. And while many of the cohorts are listed here, due to inconsistent data sets across utilities, the number of cohorts that could be quantitatively examined using statistically significant results were limited in the final analysis, which we'll show in later slides. So I'm now going to turn it over to Matej, our lead analyst, to discuss the billing data analysis methodologies.
Thank you, Christy. My name is Matej Perusi, and I served as the primary data analyst for these studies. This table summarizes the methodology steps for the smart thermostat and HVAC EFLH billing analyses. First, we screened the monthly gas and electric billing data, removed unusable and incomplete data. Next, we matched the participant tracking and installation data with the billing data. For the thermostat billing analysis, we assigned annual pre- and post-installation periods. For the EFLH analysis, we assigned only the post period, which would be the year following the HVAC installation. Next, we mapped all the participant zip codes to the nearest NOAA weather station and matched in the heating degree days and cooling degree days for each station for each monthly billing period. Then we weather normalized the billing data using the Princeton scorekeeping method, also known as PRISM. This allows us to disaggregate the heating and cooling and baseload components of usage. For the thermostat billing analysis, we obtained the final screened analysis groups before that. The thermostat billing analysis used both a participant and a control group. The EFLH billing analysis used only a participant group. Now, for the thermostat billing analysis, we matched the non-participants to participants by utility, installation year, pre-period usage quartile, the climate zone, and thermostat tier. For the thermostats, we compared the usage between smart thermostat participants and match control group to determine the final percentage savings. Next, we obtained monthly electric and billing data. For EFLH, we use billing data 1 year after HVAC installation. For thermostat, we use billing data for the years before and after thermostat installation. This table that you see is the design of the thermostat analysis cohorts. We looked at thermostat installations from 2017, 2018, and 2019, and the billing analysis used billing data ranging from 2016 to 2020. For example, for the 2017 participant cohort, the pre-period was in 2016 and the post-period was in 2018. Similarly, for the 2019 participant cohort, the pre-period would be in 2018 and the post-period was in 2020. We selected control groups based on future program participants. The control group for each cohort was based on future thermostat installations after the post-period in each cohort. For example, for the 2017 cohort, we used future 2019, 2020, and 2021 participants as the control group. We examined the usage for the 2019, 2020, and 2021 control group in the participant analysis period. using 2018 as the pre and 2016 as the pre and 2018 as the post period. Similarly, for the 2018 participant cohort, we used future 2020 and 2021 participants as the control group. We examined the usage for the 2020-21 control group for the participant analysis period using 2018 as the pre-period and 2020 as the post-period. Now I'll turn it back to Christy to discuss the Thermostat Savings and EFLH results.
Yeah, thanks, Matej. So we're now going to provide an overview of the Thermostat Savings results from the billing analysis. So this slide here shows the number of participants, the annual heating energy use, and the percent savings for programmable and smart thermostat installations installed in homes with natural gas-fired equipment. And that's both airside furnaces and hydronic boilers. We selected the thermostat tier cohort for the final analysis to be consistent with the current TRM. And as shown here, most of the utility program participants did receive tier 3 thermostats, which also achieved the lowest or best precision at 77% at 90% confidence. The percent savings ranged from 4.2% for tier 1 programmable thermostats to 5.1% for tier 2 and tier 3 thermostats with more advanced smart features. This slide shows the cooling percent savings for homes with smart thermostats. Note that we received program data for exclusively tier 3 thermostats for cooling data. The thermostat savings during the cooling season were much higher than during the heating season, which may be related to typically lower cooling loads where programmable features can have a greater impact than heating. So based on these results, we do recommend revising the thermostat percent savings for heating and cooling. So this table shows a comparison of the calculated thermostat percent savings from the billing analysis with the current thermostat percent savings in TRM version 3.3. So on the natural gas heating side, the tier 1 thermostat percent savings from this billing analysis are about 17% higher than in the current TRM. Tier 2 and Tier 3 thermostat billing analysis results are slightly lower at 94% and 93% respectively of what is currently in the TRM. And while we did not analyze electric heating percent savings due to a lack of data, we do recommend assuming that the electric heating percent savings are the same as the natural gas heating percent savings for this TRM update. And then finally, the cooling season thermostat percent savings are about 57% higher than those in the current TRM version 3.3. For residential thermostats, we also recommend updating the electric cooling and natural gas heating energy consumption baseline values based on the results of this billing analysis, which also incorporates more recent NOAA normals weather data. So this table compares the baseline annual energy consumption values from this billing analysis with the current TRM version 3.3 baseline values. So we can see here we have 75 versus 69 for natural gas, and on the cooling side, it's 1146 versus 760. Due to limited data, as you can see, we don't recommend updates to the electric heating energy consumption baseline values at this time, but we do recommend that we look into this data collection for future studies. So moving on, we're now going to provide an update or an overview on the HVAC equipment EFLH values from the billing analysis. The HVAC equipment EFLH results that we're going to show on the next few slides are all summarized by the climate zone cohort. So the 3 Minnesota climate zones are defined in the TRM as shown in the figure here, with Zone 1 covering the northern portion of the state, Zone 2 covers the central counties, and Zone 3 covers the southern portion, which also includes Twin Cities. And note that these 3 climate zones are different from what's presented in the ASHRAE IECC climate zones, which only define 2 separate zones for Minnesota. So this table here shows the natural gas boiler and furnace participants, the heating EFLH results, annual heating energy use per participant, and the average output capacity per rebated equipment. And as mentioned on the previous slide, we use the climate zone cohort for the final analysis to be consistent with the current TRM, as we also did with the thermostat measure. So while there isn't a huge difference across zones 1 and 3, note that the heating EFLH value for zone 2 is actually slightly lower than zone 3. There are more heating degree days in zone 2 than 3, so this could be related to a difference in equipment operations or something variable in those particular customers. Due to the high number of participants, we did achieve very precise results for all climate zones with less than 2.4% precision at 90% confidence. So this slide here shows the air conditioning equipment participants' cooling EFLH results, annual cooling energy use, and the average output capacity for air conditioning participants. The EFLH varied from about 312 hours in zone 1 to 567 in zone 3. Note that zone 2 and 3 were very similar. And while most of the participant data was from zone 3, it did achieve the highest precision at, or lowest precision at 1% at 90% confidence. And the precision did vary pretty significantly from 1% to almost 22% for zone 2. This slide here shows the heat pump participants, which will be of particular interest to this group. The heating and cooling EFLH results, annual cooling and heating energy use, and the output capacity per installed equipment by climate zone. So the cooling EFLH were higher than air conditioners, which may indicate that heat pumps might be used more into shoulder seasons than air conditioning equipment. But the average output was also slightly lower, which could result in higher run times to satisfy the load. The heating EFLH for heat pumps was also much higher than for gas equipment. However, we do know that there are other loads included in electric data, such as defrost energy use, fan, and drip pan heater that wouldn't be reflected in the natural gas billing analysis. The output capacity for heat pumps was also much lower than gas equipment. And heat pumps are generally sized for cooling with some exceptions. And note that these results do reflect the average heat pump customers, not necessarily customers who are planning to use their heat pump systems as their primary heating system. So without any sort of customer survey or supplemental data, we do not know what percent of the heating load these units actually served. But in all of the climate zones, we did achieve less than 10% precision at a 90% confidence interval for the heating EFLH results. Great. So this table compares the current TRM version 3.3 cooling EFLH values with the cooling values from this billing analysis. So again, to maintain consistency with the current TRM across residential HVAC measures, we recommend using the climate zone cohort for the TRM version 4.0 update. And while TRM version 3.3 does provide cooling EFLH values by home type cohort, breaking out single family versus multifamily, this billing analysis recommends breaking the EFLH down by equipment type instead, so having central air conditioners separate from heat pumps. The cooling EFLH billing analysis results for air conditioners and heat pumps are higher than the current TRM version 3.3 values, as we can see here. And this could be due to warmer summers on average, but we also know that the billing analysis incorporates other home loads, which are challenging to break out. So we do recommend additional customer billing data collection in future years, particularly for heat pumps to confirm the findings of this analysis. Moving on to heating, so this table shows a comparison of the TRM 3.3 heating EFLH values with the billing analysis results. So while version 3.3 provides one heating EFLH value per climate zone for all types of residential HVAC equipment, we do recommend breaking the heating EFLH out by natural gas equipment and electric heat pump equipment based on the results of this analysis. The billing analysis derived natural gas furnace and boiler heating EFLH results are lower than the current TRM values. This reduced heating EFLH could be due to warmer winters on average over the last few years. Again, the Zone 2 heating EFLH billing results for natural gas boilers and furnaces was lower than Zone 3, which doesn't align with the higher heating degree days in Zone 2 compared to Zone 3. However, since the precision was within 1%, we did not adjust the Zone 2 results for heating degree days. This adjustment could be up for consideration by the TRM Advisory Committee. The billing analysis derived heating EFLH values for heat pumps are significantly higher than the TRM 3.3 values for climate zones 1 and 2, but noticeably lower for climate zone 3. This could potentially be to smaller urban homes or homes that do not use their heat pumps as their primary source of heating. We also know that heat pump operation is quite different from boilers and furnaces, and the electric billing analysis likely reflects that added fan and defrost energy use. Electric heat pump heating EFLH values presented here, again, also only reflect the average heat pump customer operation, which is likely a mix of supplemental, primary, and whole home heating. So if we incorporate the results of this billing analysis in TRM version 4, we do recommend 2 additional TRM algorithm updates. So for electric heat pumps over on the left, we recommend removing the conversion from the rated heating seasonal performance factor, HSPF, to the climate appropriate HSPF for the algorithm, since this is already reflected in the billing analysis calculation. And then for natural gas-fired boilers and furnaces over on the right, we do recommend taking out that oversizing load factor, since again, this would already be reflected in the billing analysis results. And taking these out of the algorithms have the added benefit of simplifying the algorithms for our customers. So finally, we're going to wrap up this webinar with a summary of the conclusions and recommendations and talk about next steps. So in summary, for thermostats, we're recommending updating the Tier 1, 2, and 3 heating and cooling % savings and the baseline consumption values for gas heating and electric cooling. For residential TRM measures that reference the EFLH values, we're recommending updating the air conditioner, heat pump, and furnace and boiler values by climate zone and taking out those adjustment factors that we reviewed on the last slide. In terms of recommendations for future work, we are expecting heat pumps to become more prevalent across the residential sector over the next 10 years. So we do recommend continued Minnesota heat pump customer billing analysis to confirm and update the heating and cooling EFLH values by climate zone. As I mentioned on a previous slide, we also recommend incorporating some sort of customer survey to better understand how these heat pump customers are using their systems and whether they are mostly supplemental, primary with some fossil fuel backup, or really serving the whole home heating load. So finally, looking at next steps, the TRM Advisory Committee has already reviewed and provided initial feedback on these results, and we are currently soliciting feedback through the end of this month. We are planning to submit the draft TRM version 4 on December 1st, with the final version 4 released at the end of 2022. So, feel free to reach out to the Cadmus team via email or provide comments in Huddle on these recommendations. Back to you, Mary Sue.
Great. Thanks so much for that great presentation. If you have not already done so, please type any additional questions into the Q&A panel and send them to us. Laura, do you have any questions for Amalia, Christy, or Matej?
Sure. Well, first, somebody requested clarification along the way. Does the dataset only include thermostats that were recorded as part of a utility program?
Yes, all of the results that we present here were part of a utility program.
Great. Okay. Here's a question about thermostats. How did COVID impact the thermostat percent savings?
Matej, I'm going to kick that one to you.
Answer that. Actually, in the 2019 cohort, which would have a pre-period in 2018 and a post-period in 2020, we were finding considerably lower savings even after accounting for the control group difference. And that's kind of like a COVID impact from that. They were approximately like 25% lower than the 2017 and 2018 cohorts. What we did, and also most of the participants were in the 2019 cohort. So then it put a lot of weight towards the COVID cohort with pre-COVID and then post-COVID, where we expected more of an increase in usage because people were home more. And going forward, leaving that as the main cohort, having the largest sample size would have kind of biased the percent savings. What we did in the end is for the 2019 cohort, we went from January to March 2020. So then the pre-period was January 2019, and the post-period was 2018, January, March 2018, and then the post would be January to March 2020, and that would be all before COVID. And that also reduced the sample size for the 2019 cohort substantially, so it had less weight. So this is very much assuming that we're not going to have such a big drastic difference between pre-COVID and post-COVID. Eventually, as it goes forward, the pre and post differences won't be as substantial. So that's how we adjusted for this in the analysis with the 2019 cohort.
Also, for us on the thermostat study, was there a way to separate new heating or cooling equipment from the thermostat install? Many times, a new smarter thermostat gets installed with new equipment. So in other words, making sure new, more efficient equipment isn't confounding thermostat savings data.
Okay, yes. That was the first step in matching the billing data and tracking data. So we received billing data for all the programs, so it included HVAC installations and thermostat installations, and often they were stacked together for the same customer. Our thermostat analysis only includes thermostat only, people that received only thermostats and no HVAC equipment. And the sample sizes show that as well. Most people installed their thermostats with HVAC equipment, and our thermostat sample sizes are much lower because we excluded people that got HVAC equipment, and the EFLH analysis all had those customers in there, tens of thousands, and the thermostat only group looked only at thermostat savings. And there was no other program participation. We actually looked at some of the utilities provided weatherization information. We excluded customers that also received weatherization to not confound the thermostat savings and only get savings estimates for thermostat measures.
Right. Were the heat pump customers that had a supplemental heating source identified? And if so, were heat pump customers that have supplemental furnaces and boiler heat removed from the furnace and boiler evaluation set?
I can take that one. So the data sets that we received were not consistent in how they identified backup fuel sources. So for most of the program data, it did not indicate whether there was a backup heating source, or if it did, it may have just said gas or other, and didn't specify what fuel type. So when I say that the heating or heat pump heating EFLH values reflect the average customer, we are assuming that it's distributed across supplemental and whole home usages. So the EFLH values that we showed here do not indicate that those customers solely use their heat pump for heating.
So I guess staying on a heat pump question here, how did you account for possible cold climate heat pump usage in the study and varying shutoff set points on the equipment?
Yeah, so again, we would love more granularity and understanding of how these heat pump customers are using their systems. That was not part of this billing analysis, the intention of this billing analysis. So we're looking at overall average heat pump customer usage. So we don't know, with particular customers, what temperature they're switching over from their heat pump to their backup source. We understand there's definitely some percentage of customers who are still doing that, and it's probably much more common than a situation where a customer is using their heat pump as the sole source of heating.
Okay, I've got a thermostat question here, or maybe it's combined. Okay, are there recommendations for how to approach proprietary thermostats associated with high performance or cold climate heat pumps? Many high performance heat pumps and even some conventional split systems have proprietary control systems that don't comply with utility programs.
Yeah, it's a good question. If they weren't part of the programs, then we definitely didn't look into them. So, I wouldn't expect that those thermostats would, be referencing these percent savings, at least to receive incentives.
Also on thermostats, maybe I'll try to combine these two questions. Were you able to account for participants that may have participated in a utilities load management program? And did you account for customers enrolled in behavioral programs? So, yeah, why don't you address whether those, I guess, questions, how those fit in with the scope of the project, and your thoughts on those?
Yeah, on the behavioral, we didn't have information on behavioral programs, nor really the demand response components, people that get a thermostat and like a demand response component. But when on each of these, when we looked at the future control group, we looked at similar customers from the same utility. So if there was a program going on during the same time period, what we're doing is differences of differences in effect between participants and non-participants over the same time period. So if there were like other programs that were present in both groups, the differences should be netted out by using the control group. If they tended to have like more savings, for example, from having a demand response, let's say, or more cooling savings, the non-participants would have seen some savings as well, and the participants would have seen the additional savings. But when you take the difference between the two incrementally, you still get the thermostat only savings from installing a thermostat.
On heat pumps, can the heat pump hour analysis be reviewed separately for centrally ducted versus ducted systems?
Yeah, we did initially break that out as one of the cohorts. And let's see if I still have this readily available. Whoever asked that question, I'd be happy to send those results. I guess the key finding is that we didn't see a significant difference between ductless and ducted systems. It was very similar. So when we reviewed those results with the CART team, we decided to combine those into one cohort.
Another question about ductless ducting. So somebody's clarifying, so in your recommendations, I guess ductless and ducted systems have the same effective full load hours.
Correct. Yeah. So in the TRM algorithm for heat pumps, it would use the same EFLH values regardless of the system type.
Well, okay. Another question or comment. That seems odd given how those systems are designed and operated. Do you want to speak a little more to your thoughts on potential for future?
Yeah, I mean, if you want to go back to one of the heat pump results slides, I think it may be slide, let's see, 20, let's look at 27. Yeah. So as you can see here, after going through all of the data and taking out incomplete data sets. So I think for heat pumps, we ended up having to remove about 59% of the data that was provided due to incomplete data sets. We were left with only 888 participants. So ideally, we would do this for a much larger group of participants and be able to achieve statistical significance across more cohorts so that we could break down results by ducted and ductless, cold climate, ground source. But due to the limited number of data sets, we had to also limit the cohorts that we could present on. So, in an ideal world, there would be more heat pump installations that we could choose from. But this was, the statistically significant results that we could extract from the data sets that we had.
Great.
So this is 888. If you go back to slide, I think 25, that shows the natural gas and heating boiler equipment. Yeah, so number of participants here, 63,000. And I think for those data sets, we only had to remove 36% of the provided data. So those data sets tended to be more complete, and just generally there were so many more participants.
Thank you. All right. Well, we don't have any more questions. So if anybody has questions, type them in very quickly. Otherwise, I can turn it back to Mary Sue.
And I guess one last thing I wanted to mention before we move forward is I know that Jenna on our team is working on a fuel switching measure for cold climate heat pumps at the moment. So the EFLH values that we show here are probably not appropriate for a fuel switching measure. Again, we don't know what % of these customers are truly using their heat pumps as their only or primary heating source. It's really representing your typical heat pump customer. So we would definitely want to do a whole home specific billing analysis when we have a substantial data set to do so.
Great. Thanks for that.
Thank you. Go ahead, Mary Sue.
Thanks for that addition, Christy and Laura. I assume you have no more questions at this point. So thanks.
Oh, well, no, go ahead.
No, go ahead. If you got a question, go ahead.
A great transition question. When will the details behind the card study be released? So handing it off to you.
Yeah, I'm not sure where the final reports are in process for you, Laura, or for you, Adoy. I'm not sure if they're close to being wrapped up and finalized or if they're still a little ways off. But I'd say probably in a couple of months. Does that seem right?
Yes.
Based on where you are in process? Okay, so probably in a couple of months, the reports will be available. So thanks again for that great presentation, and to you, Laura, for facilitating the Q&A. If you end up with some follow-up questions after this webinar, please feel free to contact one of us. The recording on the webinar in the slide set will be available on the department's website in a few weeks. When available, you can link to either the webinar or the report from this Applied Research and Development webpage, as indicated on this slide. And this webpage also has other information related to CARD program and CARD research projects, which you can check out by going to the link at the bottom of this slide. Thanks for participating today. We really appreciate your interest in CARD projects. I just want to take a minute to mention some upcoming projects webinars. On October 25th, the Center for Sustainable Building Research at the University of Minnesota will highlight key findings from a project that investigated a novel panelized wall and roof system to enable fast and cost-effective upgrades to multifamily buildings in Minnesota. Then on December 7th, Ecometric will discuss the results of research they conducted into the motivations and barriers that drive the decisions of individual HVAC contractors working in small to medium commercial buildings. To keep abreast of upcoming CARD webinars as they are scheduled and other news related to the Minnesota Conservation Improvement Program, sign up for SIP updates through our email list. You can link to that on the slide here. There's a link. And in the meantime, feel free to contact me if you have questions or suggestions for the CARD program or for CARD webinars. And as a final reminder, there'll be a short evaluation that launches after this webinar. Please take a few minutes to fill it out and let us know how we did. Thanks so much again, and have a great day.
Yeah, thanks, Mary Sue. Thanks all.
Thank you.
Thank you.